Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about the point-slope form of linear equations. And this is a very powerful equation because it helps you write linear equations quickly and very easily and very efficiently. So before we learn how to work with the point-slope form, I just want to have a brief review of where we've been and then talk about where we're going. There are three forms of a linear equation, okay? You have the slope-intercept form, which is y equals mx plus b, where y is the dependent variable, right? Remember, that's dependent. M is the slope. The x is the independent. I heard that over there. Thank you. Great job. Independent. And b is the y-intercept. Now, the reason why it's such a great way to graph, the best equation form to graph, because all you got to do is identify the y-intercept, plot it, and then follow the slope both forwards and backwards, remembering always that regardless of if you're going up or down, if you have a rise or a fall, you always run to the right. The point-slope form, okay, is y minus y1 equals m times x minus x1. And I'm not going to talk much about that, except for the fact that that's what we're going to learn today. And standard form. Standard form we've seen, okay? I'm not going to lie to you. We haven't done oodles and oodles of work with it, but we've seen it, and I've defined its power. The power of the standard form is if and when a and b are factors of c, okay? If a and b are factors of c, then graph using intercepts. So if you think about that, the standard form is quite powerful, especially if you had something like this. 15x plus, let's say, 20y equals 60. You may think that's extremely difficult, but actually, if you think about this, hold on, let me get a little square here so I can show you guys what I'm talking about. Okay. So, why this is so important is as follows. If I have this in standard form and I have my a and my b as factors of c, I can find my intercepts really, really easily. My y-intercept will be the y value when x is 0. So the x goes away, right? So what would my y-intercept be? My y-intercept would be 0, 3. Very good. Because it's the y value when x equals 0. And then, again, if a and b are both factors of c, then I could just find my x-intercept by literally making y 0. That basically says bye-bye to the y. And then what would my x-intercept be? My x-intercept would be 4, 0, because I made y 0. And then from there, I can graph that very simply, very easily. This is going to be a very powerful tool that we're going to use when we're solving inequality word problems, especially with real-life word problems where the numbers are in the thousands. You're not going to really want to, for example, start with a y-intercept of, let's say, 7,500. Let's say that's the beginning operating costs or our expenses. And then you're building something and it costs $3.75. That's going to be kind of hard if you're starting at 1,000 and you got to go by intervals by 3.5, right, or 3.75. So that's where the beauty and the power of standard form comes in. Okay, you can always find the x and y intercept, by the way, regardless of if a or b are factors of c or not. The reason why I encourage you to graph it if and only if a and b are factors of c is because it's a very pretty number. And again, in a real life situation or in a word problem, let's say that my y-intercept was 125.67. I would accept the fact that you're going to have to estimate that on the graph, but visually I will see on paper that you have the correct answer. Does that make sense, guys? Okay. Okay, so thank you. Sorry for wasting so much time on that. Just wanted to make sure you were clear. And then today we're going to learn about the point slope form. And by far, it's the best way to write an equation. There is another way to do it. So I don't want you to think, oh, Morrow doesn't know what he's doing. No, I do. I just think that this is going to be the most efficient and best way to do so, okay? So let's get right to it, gentlemen. The point slope form, once again, it's y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is the given point, okay? Whenever you have one of these, they're going to give you either a slope in 1 point or 2 points. And if they give you 2 points, you can find the slope and then use one of those points to plug into this formula, okay? In big, bold, red letters, it says, always use the point slope form of linear equations to write linear equations. Again, it is not the only way. I just think it's the best, less confusing, and easiest way. So, let's get right to it with an example. Example 1, a line passes to the point negative 5, 2 with the slope 3, 5. Write the equation of the line in slope-intercept form. Okay. Now, let me just explain something real quick. You could do this in such a fashion. A lot of people argue with me. A lot of people argue with me because they say, Mr. Morrow, they said to write it in slope-intercept form. Why do you go to point slope form first? So let me explain the alternative way to find this. You could go ahead and remember that y equals mx plus b. They gave you a y of 2. They gave you an m of 3/5. They gave you an x of negative 5. But you don't know your b. So you can solve for b first if you want. This is going to be 2 equals negative 3 plus b. Then you could add the 3 to both sides. So b will equal 5. Now that you have a b and you had your slope, you can go y equals mx plus b. So again, you can plug in the slope they gave you. You can plug in the x and y they give you and solve for b. And then from there, rewrite it with the m and the b. You can do this. Here's the only problem. This is not going to be very useful as we continue. It's not going to be as efficient. And also, and the SAT or the ACT or my test or my quiz, I may say to you, I want you to write this equation in all 3 forms. Point slope form standard and slope intercept. You'd be out of gas doing it this way. All right? But this is one method. Now let me show you why I like my method better. My method, find the slope and label the given x1, y1. So I'm going to erase this part, okay, guys? Thank you. So my method, or the point slope form method rather, it's not my method, I didn't invent it. Find the slope and label the given point x1, y1. Okay, so that's x1, that's y1, and m is my slope. They gave it to me, we're all good. Now, step 2. Plug in the slope and the x1, y1 into the point slope form. And you're done. The equation is now in point slope form. Now, in order to convert the equation into slope-intercept form, simply solve for y. So check it out. I've got y minus y1, which was 2, equals m of 3/5 times x minus x1, which is negative 5. So remember, this is a minus negative 5. Thank you for catching that. I heard it. Good job. You got to remember that it's minus a negative here. So at the end, this is y minus 2 equals 3/5 times x plus 5. Guys, if they ask you for point slope form, you are done. That's it. It's done. You're done. That's your equation. You're done. Moral, how is this useful at all for us? Let me show you. If you have the point slope form, okay, okay. What's the x1, y1 here, guys? Thank you so much for that. I'm so proud of you. You guys realize, okay, that's opposite because it's x minus x1, so it's negative 5, and that's y minus y1. So the point that I'm starting here with is negative 5, 2. So negative 1, 2, 3, 4, 5, 1, 2. Guys, what's the slope? So up 1, 2, 3 over 1, 2, 3, 4, 5. Down 1, 2, 3 over 1, 2, 3, 4, 1, 2, 3, 4, 5. And there it is. So you can read and graph from this form very easily. So that's point slope form. You're done. Now, I had originally asked for this, though, in slope intercept. So now we simply solve for y. So we have this y minus 2 equals 3/5 x plus 5. How do we solve for y here? Distribute. Very good. So I've got y minus 2 equals 3/5 x plus 3/5 times 5 is 3. Add the 2, and bada bing, bada boom, you now have it in slope-intercept form. Okay. Now from here, if I wanted to, I can ask you to go to standard form as well. And just for giggles, what would we do if I want to turn this into standard form as well? Yes, sir? I am very proud of you, son. You're going to subtract 3/5 x to both sides. And you're going to have negative 3/5 x plus y equals 5. But am I done? Why? I am so proud of you, sir. Give me some high five love. Good job, man. Great job. That was a weak high five on my part. All right, there you go. What my boy just finished saying made me very happy. He said, "More, you can't have a fraction as a, and you cannot." So how do I get rid of that denominator of 5? Multiply by 5. So my true standard form here would be negative 3x plus 5y equals 25. Does that make sense? And then some teachers are very technical about it, and they don't even want the a to be negative. But you can keep it as an integer for me. Does that make sense, guys? May I continue? Because now it's pretty much just practice for the rest of the day. Okay. So let's do this. Write an equation in both point slope form and slope intercept form. Okay. So I've got y. Wait. Follow directions, modal. Is my slope is negative 5, so m is negative 5. That's my x1. It's my y1. Stay focused, moral. So now I got y minus y1 equals m times x minus x1, so it becomes a plus 3. Does that make sense, guys? That is point slope form. I am done. I am done. Now, if I want to go to slope-intercept form, simply solve for y, distribute. So y equals negative 5x minus 9. Did you have a question, my brother? You got it? How about anyone else? How are we doing here? It's not so bad, is it? Not so bad at all. Can you see why I like this point slope form better than solving for b and then plugging it back in? I think there's just too many ways to make a mistake there. Yes, sir, my brother. Please. Slope-intercept, Well, I don't know what, I'm going to try and be rude, but I don't know what you meant by that statement. You said you got to multiply everything. I don't know what that means. I No, I don't know why. Okay, why are you saying you got to multiply by 9? I'm just curious. No, 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 no. But that's if you're going to standard form. If you're going to standard form, the reason why I multiply by a 5 here, my brother, thank you again, is because I want it in standard form, and I need my a and my a to be an integer. Thank you, kid. Now, why are you saying sorry? So that's my job, kid. Now, just to follow that up, though, if I wanted, just for giggles, if I wanted now to turn this into standard form, in this case, though, my brother, would I have to multiply by anything? No, because I have y equals negative 5x, 5x minus 9. So if I want standard form, I want the x and y together on one side, but I want a to be an integer, which it is at this point. And now I'm golden. I have it in standard form. Yes, sir.
Oh, so you wouldn't always need a fraction.
Sometimes you're going to have a fraction as a slope. Sometimes you're not. If you have a fraction as a slope and you bring over an x that has a fraction as a coefficient, you got to multiply by the denominator to get rid of it. Thank you. Stop apologizing. You're caring. You're a good kid. Thank you. Does that make sense to everybody, though? Promise? May I continue? Okay. What happened? What happened? What happened? All right. Example 3. Now I'm giving you a line that passes through 3, 2, and 5, 8. What is an equation of the line in both point slope form and slope intercept forms? Okay, now you may say, whoa, wait a second, it didn't give us a slope. What can I do, my brother? I'm sorry? Okay, you can use either point, but that still doesn't answer the original question that I asked, which was, where's my slope?
Oh, you have to solve for it.
Yes, sir.
You could put x1, x, y1, x2, and y2, and then you subtract y2 minus x1.
Yes, you find the slope. You go x1, y1, x2, y2, brothers. Now we find the slope, guys. I didn't give you the slope here. I gave you 2 points. But hopefully you have in your arsenal of tools, in your toolbox, the equation for slope. So, yes, sir. So it's y2 minus y1 over x2 minus x1, which equals 8 minus 2 over 5 minus 3, which equals 6 over 2, which equals 3. And that's my slope. Now, the question was, can I use either point? Can I use x1, y1 or x2, y2? Absolutely, but why confuse yourselves? I stay consistent. I'm going to use the x1, y1 that I chose. But I don't want you to think that if you use this point, it's going to be wrong. I will say this. Your form of the point slope form will be different than my form of the point slope form because we use a different point. But when we go ahead and solve for slope intercept form, they're both identical. Okay, I need you guys to understand that. Okay, so let's do this. Tell me what to do. Okay, tell me what to do correctly though. Okay, y minus 2, thank you. 3m times x, minus x1, which is 3. Very good, gentlemen. Thank you. So now I got y minus 2 equals 3x minus 9. So y equals, add the 2 to both sides, equals 3x minus 7. This is slope-intercept, and this is point slope. Questions, comments, concerns, issues, problems, dilemmas. Does that make sense, guys? It's not too bad, is it? Yes, sir.
So in theory, you can have an infinite amount of point-slope equations for that one
That
point.
is a brilliant question. What my boy just finished asking, he said, in theory, you can have an infinite number of point slope formulas. And the absolute answer is not even in theory, 100%. Because think about it, a line is made up of an infinite number of points, right? And it is. Now look, guys, I will prove what he's saying. Let's just say that I use 5/8 instead. I want to do real quick, but just so you can see. So y minus y1 equals m times x minus x1. Totally different point slope forms. Totally. But if he's correct, when I solve for y into slope-intercept form, it's going to be the same. So let's see, y minus 8 equals 3x minus 15. Add the 8, add the 8, y equals 3x minus 7. That is perfect. Because since every single line is made up of infinite number of points, I can put any point in the point slope form. And we're going to have different point slope forms, but it's going to be the same line because I'm using points that are on the line and I'm using the same slope. Sir.
So then that means that you can use either or.
Yes, sir. So we can use either one of these. You can either use 3-2 or 5/8, but I go back to stick to the standards so you don't get confused. But yes, the theory here that we just went over, brilliant. Thank you. May I continue? Okay, what is the graph of this equation? Okay, now, some people are going to go ahead and turn this into slope-intercept form, which is fine. There's nothing wrong with it except you're going to have a nasty fraction as a y-intercept. Or you could recognize, hey, wait a second. This is the point slope form. So this is y minus y1 equals m times x minus x1. So if that's the case, what's my x1, y1, brothers?
2 and 1. Negative 2 and 1.
2 and 1. Why? Think about it, guys. If y is 1, what's y minus 1? Y minus 1, right? If y was negative 1, wouldn't it have been a plus up here?
Yes.
Okay. Do you see that? And then the x, it's x minus x1. So since it's x minus 2, that means x1 has to be 2. If x1 was negative 2, then that would be a positive 2. They're opposites. You see this, right, guys? Thank you. Yes, sir. Oh, okay. Sorry, Papa. Okay, so now, what is the graph of this equation? Very simple. Let me get a little graph paper up here. Hey, wait. Where did that go? All right, there we go. All right. What's the x1, y1? 2, 1. So go 2, 1. Now, guys, if I've helped you learn anything, what do we know about the slope on a particular line?
But it's linear, but
It's that it's always constant. Very good, guys.
constant.
It's always constant. Good job.
I thought I thought it was
So since the slope is always constant throughout a line, I'm going to go up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Remember, guys, it's like a staircase. Remember, a staircase is never going to go like this and then like that, right? It doesn't happen like that. A slope is constant throughout its own line.
I guess I thought about the ladder though.
All right, does that make sense, guys? Promise?
Yeah.
Okay, let's continue. Now, here we go, guys. If you know point slope form, we can easily segue into perpendicular and parallel lines. How to write equations for lines that are parallel or perpendicular to a given linear equation or graph going through a particular ordered pair x1, y1. We already learned about parallel and perpendicular lines. We know that parallel lines have blank slopes. Thank you. have equal slopes, the same slope. Thank you. And then we know that perpendicular lines have slopes that are blank blanks of each other. Negative reciprocals. Very good. Thank you. Thank you, guys. Very good stuff here. Number one. Whenever we're doing this, guys, please, all joking aside, be careful to read, okay? And always, I know I'm a pain, but guys, find the original slope, please. Yeah, find the original slope because that's going to tell you where to base your stuff from, okay? Then find your parallel slope or your perpendicular slope, okay? If your original slope is 5, for example, label parallel slope is 5. Label perpendicular slope is negative 1/5 because that's the new slope you're going to work with. Now, step 3, plug in the given x1, y1 and the new parallel or perpendicular slope, depending on what they're asking, into the point slope form, and then you solve for y into the slope-intercept form. So, hopefully some of you are saying, so there's nothing different than what we just finished doing, except I just got to find the parallel or perpendicular slope. And again, that's why the point slope form is so powerful to me. Okay? Very useful, very quick. Does that make sense, guys? Question? Okay, thank you, Papa. Okay. Now, write an equation of each line in slope-intercept form, which is A, parallel to y equals 6x minus 2 passing through 1, negative 3. You know me, guys. I'm a big labeler. I strongly suggest you do this. This is x1, y1. It takes 2 seconds to do it correctly. Now, what's my original slope? Very good. What's my parallel slope? Hey, guys, now I'm done. Now I have everything I need, and that's where sometimes we fail to really follow through and we hurt ourselves. My brother. Okay, thank you so very much. Remember we have y equals mx plus b? So m is the original slope. Since it's a parallel line, parallel lines have equal slopes, so m has to equal 6 for the parallel line as well. Thank you, my brother. Now, step 3, plug it into the point slope form. Y minus y1, so that's plus 3, equals m, but I'm talking about my new parallel m, which is 6 times x minus x1. And now step 4, solve for y. So y plus 3 equals 6x minus 6. Subtract the 3 to both sides. Y equals 6x minus 9. And ding dong, the witch is gone. Talk to me, sir. Yeah, no, it's not that I changed it. I just plugged it into the formula. It's y minus y1, so a negative and a negative is a positive. That's how I got that y plus 3. Thank you for caring. The number one thing that most people do incorrectly here, guys, is they fail to write their new slope, and then they end up writing the same equation. Okay? So please be careful with that. Yes, sir. I had a but. Let's go. What's up, my man? No, it is not. For parallel, it is the same slope, but it has a different y-intercept. If it had the same y-intercept, then they wouldn't be parallel. They would be the same exact line. Thank you for caring. Thank you for asking. Those questions are important. Thank you, kid. Okay, now I want it perpendicular to y equals negative 4x plus 5 and passing through 8, 5. Please be consistent. Heck, oh, I love it when it does that. No worries. We get through it all. Okay, so this is x1, y1. What's my original slope? Thank you. Excellent. What's my perpendicular slope? 1/4. Thank you. Now we have everything we need to rock and roll, brothers. So step 3, y minus y1 equals m times x minus x1. That's point slope form. But usually when we're working with graphs and equations and functions, we want it in slope intercept. So I've got y minus 5 equals 1/4 x minus 2 plus 5 to both sides. So y equals 1/4 x plus 3. And that line is perpendicular to this line, and it's going through this point. Please don't just go through the rhythm of doing what I'm saying. Go through that rhythm, and I thank you, but try to understand what is it that we're doing. What are we solving? What are we finding here? How can I analyze this? How can I graph this now? Try to think about where's the y-intercept? Where's the slope? See how it all fits together, brothers. Yes, sir. Thank you, sir. Thank you very much for the question. It's a very good question. The original slope is -4. Perpendicular slopes are negative reciprocals of each other. So if the original slope was -4, then the negative reciprocal is you flip and multiply by a -1, so that'd be positive 1/4. Thank you so much for that brilliant question. Thank you. Next. Okay, thank you very much, though. Appreciate that honesty. Now let's separate the men from the boys here. I want it perpendicular to y equals 6 passing through 5, 3. Huh? Ruh-roh. Guys, what's the slope of a y equals 6 equation? So does that mean that my original slope equals 0? Okay, so what's my perpendicular slope? And what kind of an equation do we find with an undefined slope? An x equals. So x is going to equal, what's the x value that this equation is going through? 5. So x is 5. Let me show you visually, because I think sometimes showing this visually helps out even more so, okay? Let me go ahead and shrink this up a little bit. Okay, so I originally have y is equal to 6. So I go 1, 2, 3, 4, 5, 6. That's my equation, y equals 6. We know that the slope is 0 in a horizontal line. Guys, if it's a horizontal line, isn't a vertical line going to be perpendicular to that? So that's why I need a undefined slope to be perpendicular to a 0 slope, and an undefined slope belongs to an x equals equation. 5 is the x value that it goes through. So 1, 2, 3, 4, 5. And you go straight down because it's vertical, and these guys are now perpendicular. This is a very good question that you can get in literally 2 seconds, or you can spend 5, 10 minutes on it going, huh? So let's learn it. Let's understand the concept. Does that make sense, gentlemen? May I continue, gentlemen? Thank you. Write an equation of each line in slope-intercept form which is parallel. Okay, I'm gonna go out on a limb here, but I believe in you. Who wants to do it live? Let's go. Do it, my brother. All right. So people watching, this is a student doing it, so please do not judge him. Just kidding. He's going to do great. Well, he's starting out semi-good. I wish he would have labeled his, there you go. Now he's labeling his x1, y1. Now he got his original slope of 2. Okay, and it's parallel. So his parallel slope is also going to be 2. Very good, my man. And now he's going to plug it into his point slope form. So he's got y minus y1. That's okay, but if you're going to do that, be careful. Just put a little parenthesis right there because it's multiplying. You're doing great, kid. You're doing great. Okay, equals m. He got it. Times x minus. If you want to go ahead and do that math immediately, you can. The reason he put a plus 3, guys, is because it's x minus negative 3, and a negative to the negative is a positive. Keep going, my man. You got this. You got this. I'm so proud of you. Wait. Okay, hold on. No, you still got this. I'm just going to try to help you clean things up a little bit, and I'm also going to shrink this down a little bit so you can have some space, and then I'm just going to give you one pointer. May I? Okay, check it out. What I suggest, clean it up before you start solving for y. So what do I mean by clean it up? Yeah, go plus 1. Now, if you want, now distribute from there. Thank you, kid. As I walk around, I should see everyone doing this or done with it already. Please do not wait for it to be done so you can just copy it. That's not learning. That's just copying down a problem. And bam. Perfection. Does everyone see this? How he did this? Why he did this? Promise? All right, let's do this. All right. I got high hopes. High hopes. Who wants this one? Come on down, brother. Let's go. Remember, you're on my channel. This is a live video. I know you're going to do us proud. Okay. He's going down a dangerous route. He's 100% accurate, and I'm extremely proud of him. But I do not recommend it for everyone, okay? I think everyone can do what he's doing, but I would be very cognizant of it. I'd be careful, and I'll explain what he did now in a second. He just skipped a bunch of steps, which is fine, as long as you know what you're doing, which he does, guys. This is exactly perfect. He's doing it great. 18. You're welcome, my brother. Oh my God, he just loves to skip steps. But you know what? I can't argue with the right answer. I would have given him 100% credit on a quiz or test like that. Great job. I hate the way he did it. I absolutely despise what he did. But I'm kind of being semi-sarcastic. I'm extremely proud of the fact that he gets it. Super. Guys, not everyone is going to get it so quickly. Again, I know I'm a pain. I like to label just to show myself. I like to label just to show myself that the original M was 2/3. He nailed it, though. The perpendicular slope is -3/2. He did this perfectly. I'm just, I'm being a little bit spoiled because I want you to label. But he got it. Great job. I don't recommend it for everyone unless you've done a lot of these and you really, 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 really know it. And even then, even I make mistakes, and I've been doing this for 20 years. Okay. Great job, kid. Does that make sense, gentlemen? Any other questions here, brothers? Thank you so very much. God bless you. Hope you learned a lot and have a great day. Thank you. Bye-bye.